Hey guys, this is Chris. I'm back in the electric train lab, and today I'm working on a Lionel OO whistling tender, and I just ran across a failure mode that I've never seen before, and I wanted to share with you guys. First off, a quick back story on this tender is that it came to me a couple months ago with the understanding that the whistle doesn't sound as good as OO whistles normally do. Previous owner told me they tried to service it, but nothing they did made any difference. And they were curious if I were to be able to fix it, and they wanted to know what it is that I find. So this video will also document that. So when I first tried it, the sound of the whistle definitely matched what the previous owner said. Decided the best course of action was to disassemble it, service it, and reassemble it. I did make a few adjustments along the way. The one that made the most change was that the brush springs were different tensions, and so I made sure that they both had the same amount of tension, and that actually made a lot of difference, but it still didn't fix the sound of the whistle. So I'll have you listen in. So that's where we are right now. It still doesn't sound great. Knowing what the problem is, I would describe it as it doesn't have as much volume or intensity. I can hear one of the tones, but the other tone is decreased in volume, and sometimes it cuts in and out, which is a weird symptom. So I was about to really dig in and start some deep troubleshooting with this thing when I remembered something I had noticed during the servicing, and that is the wires to the brushes are reversed from what I have seen on all my other OO whistling tenders. The effect of that would be to reverse the direction of the motor. And I thought that was kind of a weird thing to find, but I decided that would be my first troubleshooting step. So let me do that, and then you can listen in. So hopefully you can hear that. The volume is definitely increased. I feel like the intensity is a little bit higher, and I can now hear clearly both tones in the whistle. And I was about to declare victory, but I wanted to know, why would the direction of the motor affect the sound of the whistle? And so I started thinking, and if you could sort of use X-ray vision to look at the inside of this whistle chamber, it would basically look like this. This is the whistle chamber, this is the impeller. The way the impeller was spinning with the original wiring was clockwise, which to me doesn't make a lot of sense. It seems like it would probably be pulling air out of the whistle chambers. And when I reversed the wiring, that caused the direction of the motor and the impeller to reverse, which causes the impeller to now spin in the counterclockwise direction. And that feels a little more like it's blowing air into the whistle chambers. That's just kind of my theory. I'm not quite sure if the airflow actually works like that. And that sounds like a good theory, but I wanted a little more confirmation for that. And so I pulled out my Lionel Trains repair and operating manual, and in there's a good section on post-war whistling tenders. And all the information in there applies to pre-war whistling tenders, including the OO whistling tenders like this one. And in the repair tips section, it actually said the motor needs to spin counterclockwise, otherwise you will get little or no volume out of the whistle. And digging a little bit deeper, there's some exploded parts diagrams, and you can see a post-war tender whistle chamber, and it looks very much like the OO one here that I drew, in which case the post-war impellers do need to spin counterclockwise to, in theory, blow air into the whistle chamber. So I feel like that is enough confirmation to say that yes, the whistle motor on this tender was spinning in the opposite direction, causing some low volume and low quality whistle sound. And that is a failure mode I have not run into before. most of the tenders I've serviced have been, post-war whistling tenders, and I feel like they are assembled in such a way that you can't reverse or are unlikely to reverse the wires to the brushes. Whereas on these double O motors, the wires are actually long enough that you could obviously reverse them to the motor. So that's just a interesting failure mode I wanted to share with you guys. Hopefully you'll find it useful and maybe you can use that information sometime in the future. Well, I have a tender to rewire, so I'll leave you there. Good luck on your train repair adventures. Thanks for watching. We'll talk to you later.